Okay, we are on lesson 11 now, titled Extension Methods and Code Reuse. And of course, these two topics do not need to be talked about together, but as you know, I do. I like to take two things that aren't obviously related and smash them together for the sake of timing and for the sake of being in a college course format. So we're going to smash these two together and talk about them both in lesson 11. So with that, let's review our developer tools diagram. So the new thing here is this .NET executable. So .NET is the development environment that we use to write our C# programs in, and it's supported by Microsoft, and there's a bunch of tooling available in it, and so forth. But we're going to use this .NET executable to interact, the console application, we're going to interact with the artifact section on Azure DevOps. So we'll see that in the exercise. So that's the only new tool, and of course we're going to learn some new C# stuff, but it's also worth mentioning that Visual Studio uses, well, it uses many things, but one of the things it uses is this .NET executable under the hood. So Visual Studio provides this nice graphical interface for us, and from that graphical interface, it will contact tools such as the .NET executable to do things for us. Okay. Okay, to introduce extension methods, I want to start by motivating the topic with a simple example here. So the example is we want to be able to, given a date or a date time more specifically, we want to be able to calculate the quarter of the year that the date time falls in. Okay, so here's our program, right? So it asks the user for a date, and we want to calculate the quarter and then print that back out. And this is what it looks like when it's actually ran and executed and input is entered by a user. So the key to this example, though, is we want to do this without adding more code to the main program. We want to be able to calculate the quarter of the year on this line without making the public static void main method any longer. Okay, so there's a few ways that we can do this, but before we do it ourselves, we should first check if Microsoft did it for us. So, one thing you might do when you're in this situation is you might pop open the IntelliSense window and scroll through all the methods and all the properties that are available on the object at hand. So the object at hand is a datetime object, and scroll through and see if there's anything that already calculates the quarter of the year for us. And there isn't. We won't find that in here. So we're going to have to do it ourselves. So one way we can accomplish this goal of calculating the quarter on this line is, of course, adding a static method called getQuarter that performs the logic that for us. Okay, so this is allowed, right? This is legal because we didn't add a new line of code here. We added a new method, and we call that method on this line, and it calculates the quarter of the year for us. And this example is simple enough that we should understand how it's working. Okay, so that's one way to do it, is creating a static method. There are some other ways. We'll get a little creative here. So if we think back to our discussion of object-oriented programming and inheritance, sometimes inheritance can be used to do something like this. And it won't work in our case for a datetime object because datetime is a sealed class, which means it cannot be inherited from. But let's pretend that it did work. Okay, so this is what it would look like if it was allowed. You would have your inherited datetime class that inherits from datetime, and so we're saying that the inherited datetime is everything the datetime is plus whatever we put in here. And we have the constructor, and when we call a constructor the base class from the constructor, and then we have our one method that we want to add on top of the datetime class. So this is what it looks like in theory with inheritance. In practice, it doesn't actually work. But notice how our main program would look if it did work. If it did work, we could go user to enter date dot get quarter. Okay, so see the difference between that. So here with a static method, we have get quarter, and we pass in the user enter date. And here we have a user to enter date, and we call dot get quarter. So the syntax is arranged a little bit differently. Okay, so the inheritance doesn't work, but there's another strategy, somewhat common strategy, depending on what you're doing, and that's called creating a wrapper class. Okay, so a wrapper class is a class that encapsulates an object of another class to add functionality or to restrict functionality. So here we have the datetime wrapper class, public class datetime wrapper, and it encapsulates a datetime object here. Okay, so we have a private field, and we can see that the private field is going to store an instance of a datetime object that gets passed in through the constructor. Okay, so we've wrapped a class around another object here, and the method available on this wrapper class is this get quarter. Okay, so it performs that same logic by observing the properties of the object that it's encapsulating and then returning that result. And so you can see this provides the same interface in our main program. So we can still go user enter date dot get quarter, but the key is here this prompt for date is returning a datetime wrapper. It's not returning a datetime. So, but that gives us access to this method. So this is a somewhat common strategy. You'll see this in C#. It's even more common in Java because of what we're going to show here. Next is not available in Java. It's not available in Python, at least not in the same way. And that is extension methods. So this is a C# specific feature here, and I think it's really convenient. So on this slide, we have created an extension method to do the same thing as we've done in the previous slides. And so let's break down the syntactic features of an extension method, right? So an extension method needs to be located in a static class. Okay, so I have a static class called datetime extension, so we got that. And an extension method needs to be a static method, so we have a regular method here with the static keyword here in front. And the keyword in all of this is this, right? Literally this word here changes everything. This makes it our method promoted from a regular static method to an extension method. Okay, so just by adding this word, and it denotes that we're extending the datetime object. Okay, extending the datetime object. That's why it's this datetime, and then the name of a parameter. So same logic inside the method though, and you'll see here when we do that, when we create an extension method, we're still able to use a datetime object, and then we can go user enter date dot get quarter. Okay, so to see them all side by side, we have the static method here, and the static method, given a date time, you call get quarter and then pass in your date time, and you get back what you were trying to calculate. We saw the wrapper class here, so this is how it looks with the wrapper class. You get quarter is not part of the date time, so you wrap it in a datetime wrapper, and then you can call the wrapper dot get quarter. Okay, that's what it looks like here. And then the extension method is like a mix of those two. We work directly with a datetime object, but we can call get quarter as if it was part of the object. So that's the key here. It makes it feel as though this method came with the datetime object. The extension method makes it feel like that, whereas this doesn't really feel like that. It feels like someone implemented the get quarter method, and we kind of shuffling our data over there to do it. So it's all about how it reads and how it looks in the program. So that's the extension method there. So we'll do another example here. So let's say we wanted to write an extension method to convert a Boolean to a yes or no string. Okay, so say we have a Boolean, and we want something that reads like this: my bool.to yes no string, and converts the Boolean to a string, and we print it back out. So here I have this blocked out for the in-person lecture, but I'll just go through it here. So because we want to convert a Boolean to a string, our return result is still a string. Okay, and what we're extending is a Boolean. So this bool, extending a Boolean, and then implementation is trivial here. So that's what it looks like. What you're extending is the first parameter of the extension method, and it has this right here. And then you return whatever it is you want to return from that. Okay, so another example. So with parameters, okay, so you'll see these methods don't have parameters, right? It has this kind of magic parameter here, right, that gets magically shuffled into the method when we go, my object dot call my extension method, but it doesn't have any parameters in addition to that. Okay, so this is an example of that. So in the previous homework, we had to calculate the expired cookies, where an expired cookie is defined as having a bake date that was older than 7 days ago. Okay, so a lot of you and I wrote code that looked something like this. So calculated what 7 days ago was, and then you looked for where the bake date was less than 7 days ago. And this is kind of, this is fine, this is accurate, but in programming you can have this notion of something feeling fluent, reading fluently, and the less than sign while working with datetime objects it's not obvious to me that this is older than 7 days. It's not obvious that's what that means to me. I kind of have to decode the syntax a little bit. So if we wanted to read more naturally, more fluently, we could create an extension method with an additional parameter to do this. So we have this extension method called older than. It returns a Boolean because where wants a method that returns a Boolean, and it's extending the datetime object, and then it's also taking another datetime object as a parameter, and then you can see when we go to use it, it reads much more fluently, like give me the cookies where the bake date is older than 7 days ago, right? See how nice that reads? It's obvious to me what's going on there. So whereas this might take a few seconds for me to wrap my head around it, okay? So you can see older than, right? So the first parameter is bake date, and that gets shuffled into date 1, and then the second parameter is 7 days ago, and then that gets shuffled in as the date 2 parameter. Okay. Okay, so let's just acknowledge a few more examples that you might write extension methods for. So we saw these first three, the ones in bold. And here are some kind of similar examples here. So write an extension method to get the date of the start of a week. So extended date time, and given that date time, get the date of the start of the week of that date time. All right, right, something like that. Convert a list of strings to a delimited list. So you can write extension methods on the list object, of course. You can write them on any object. And you have a list of strings and you want to turn them into one string that's comma delimited. And you write a little extension method for that. Extension method to check if a string is a valid email address. Write something there. You could write fluent ways to serialize and deserialize objects. You can write extension methods for all sorts of things, but these are kind of similar examples here. So one other thing to note is that LINQ is entirely implemented through extension methods. And you can observe this by hovering over a where clause or a select clause or an order by clause. Any of these LINQ methods, if you hover over them, you will see, Visual Studio will tell us that it is an extension method. It'll have this little tag right before denoting that where is an extension method. And so what that means is if you had the code for a list object, if you had the list class and you could look at the code in that class, you would not find a method called where in the list class. You wouldn't find it there because it's an extension method. So it could be anywhere else, right? It could be anywhere else, but it won't be in that list class. So this is kind of an interesting thing because when Microsoft released LINQ, they also had to release extension methods. I mean, it's entirely implemented through extension methods. So extension methods were kind of a language feature that had to be added to C# in order to provide the functionality we see with LINQ. So kind of an interesting observation there. And so, okay, so now we will transition into the topic of code reuse. Of course, code reuse is a good thing if we can reuse either code that someone else wrote or code that we wrote instead of writing new code. That's a good thing. That's an efficiency gain. You know, we're saving time by writing code that is reusable. And so one thing we want to observe with extension methods, and kind of the reason I've combined these topics, is that a lot of extension methods are inherently reusable. For example, given a list of strings, create one string that's a comma-separated list of all the strings that were in the list. Right, so that's something you might want to use a lot in a lot of different of your applications. Or an even better example, an extension method that determines if a string is a valid email address, right? That's like every app ever needs to determine if a string is a valid email address that your user entered, right? So another good example of an inherently reusable extension method, or just really a reusable piece of code. Doesn't necessarily need to be implemented through an extension method. Okay. With this idea, we're going to introduce the notion of a class library. Okay, so when we've talked about libraries before with NuGet and NuGet packages, and this isn't too different from that. So in Visual Studio, we have the solution level, right? It's the solution level, and the solution can contain one or more projects, right? So this one contains 3 projects. And these 2 projects here, we have some council app and some other council app. These are council application projects. They create council apps that do things. This one up here, called Common Code, is a class library project, and it contains code that we want to share across our other apps. Okay, so you know, and in this case, it's extension method. So what we're doing here is in these council apps, we can add a project reference to our common code, and that will allow this program to use the code in here. And we can do the same thing here, add a project reference saying that this project references common code, and then this can use the code in here. So now we don't have to duplicate code across these 2 different apps. We can have them both use code that is located in this common code class library. So that's what's going on there. A way we can share code across our applications. And then one last thing I wanted to mention here was namespaces. So we haven't explicitly talked about namespaces, but I'll just do it here. So all a namespace is a container used to contain related classes. A common thing you'll see is that a namespace typically aligns with a project name by default. So the common code is the name of our class library project, and our namespace is probably going to be called common code. And all our common code or all our classes or extension methods or static methods or what have you is all going to be in the same namespace common code. It's just a container for related stuff. Okay, so with that, we will move to the lesson 11 exercise. Okay, so here is the description of the lesson 11 exercise. And the goal of this exercise is to, for one, write a few extension methods just to get some practice with that, as well as to see how we can split our code out into class libraries. So there's some starting code from this for this exercise located here. And what I've done is I've cloned it in Visual Studio here. And we have this app. And we want to write these four extension methods in a separate class library. So extension method for the random object that flips a coin, returning heads or tails. An extension method for int that returns true if it is between two numbers and false otherwise. Extension method of a string that returns how many words are in the string. And an extension method for list of string that converts the string to a delimited list. Okay, so these are our four extension methods, and we want to implement them in a class library. So here is our console application, and you'll see we just need to implement these few lines of code here. Okay, so let's set up our class library. To do that, we want to right-click on the solution and do add new project. And so far in this course, we've been adding new console applications, but we don't want to do that. We want to add a new class library right here. Okay, so I select the class library, and I'm going to call it common code. And we'll go next, and .NET 7. And now we can see it comes with a class here, a default class. I'm just going to delete that. Oh, I'm going to try to delete that. And I'm going to add the class myself. So add class to common code, and I'll just call it extensions. Okay, so we got the extensions class here, and we need to make it public static. By the way, the internal keyword that I have not said what it does yet, the internal keyword means only code from inside this the project. So only code inside common code for this example is able to access this stuff. So it's a little more restrictive than public. Public says not only can code within common code access this, but also code anywhere. So code in the console application, for example. So that's what internal does, but of course we want it public in this case because we want to be able to reference this code from elsewhere. So let's write the first extension method here. So an extension method of random that flips a coin. So public static. So we want to return heads or tails. So the string heads or tails. And we want flip coin. And we are extending the random object. Rando obj. Good. And so we want to do something like random, or what do we want to do? Rando obj dot next int 64. and we want to flip a number between one. We want to essentially want two options, 1 or 2, and if we do that, if we do this here, I guess if we do this here, then we will get either 1 or 2 as the result. And so if num equals 1, then we return heads, else we return tails. Okay, so there's our extension method for a random object. Allows us to flip a coin. And so let's comment out this stuff real quick. So highlight it all, and I'll hold Control and then press K and then press C, and that comments that all out. And let's see if this works. So we have some random object here, and now we should be able to go random.flip coin. Oh, but it doesn't know where that is. So this is where we add the project reference. So our code in our application can contact the code in common code. So to do that, we will right-click on dependencies and click Add Project Reference, and then check mark common code here. Okay, now it has that reference, and hopefully that will go away. Flip coin. Okay, so let's do this. Let's do this. Okay, so I'm looking in the debug file. You'll see there's a DLL that corresponds to the lesson 11 console app.dll. Okay, so that makes sense, right? We saw that before. But what we're also going to need here in order for this application to run is a DLL for the common code. So let's go ahead and do a build rebuild. Why are you saying that? Oh, you know what? What if we did using common code? Okay, yeah, okay. So sometimes Visual Studio figures that out for you, but evidently this time it did not. So now let's try that build again. If we do a build, rebuild. Okay, you'll see Visual Studio generated the common code.dll. So now the console app code is in this folder, and the common code DLL is in this folder. Okay, so that's how it's able to run this code that exists elsewhere. Okay, so let's try it now. Okay, we get tails. Let's try it again. See if we can get a heads. Good, we get a heads. Okay, so flip coin seems to be working. All right, let's do the next one here. So we want to be able to check if a number is between two other numbers. Okay, so some number will be a random number between 1 and, well, now it'll be between 1 and 20. And extension method will check if it's between 1 and 10. All right, so to do that, public static, so it'll just be a bool we're returning. Either it is between the two numbers or it's not. And we could do something like maybe is between. And what are we extending? We're extending an integer, some int, and we're checking if it's between two other numbers, num1 int num2. Okay, good. If some int is greater than or equal to num1 and some int is less than or equal to num2, then return true, else return false. Okay? So now we can do something like some number is between 1 and 10. We can try that out. Okay, so here it says the number is between 1 and 10. The number's not. Okay, so it seems to be working. By the way, with this, you know, we're checking if some condition is true, and then if it is true, we're returning true. Otherwise, we're returning false. We could simplify this a little bit. I mean, it already is pretty simple, but if we want, we could also write something like this, right? If you know, if you prefer, we could wrap it in parentheses. If this thing that we were checking in the if statement is true, well, then just return the fact that it's true. Otherwise, return the fact that it's false. So a little bit quicker way to write this, or I won't even say quicker. I'll say a more concise way to write this. Okay. All right. So there's that one. Okay. Next one. Write an extension that, or given a string, write an extension that contains how many words are in the string. Okay, so we want to do that here. So it'll look something like my string dot, I don't know, calculate word count. Okay. And then, of course, it doesn't exist yet. But we'll go here and we will. So we're getting a word count, so the return type should be an integer. Calculate word count. And we're extending a string. And we don't need any other parameters. And now the implementation for this, you know, we could do something like, well, yeah, let's do this. So we want to split the string. That split. Some string. Wait, no. We're splitting the string at the space. Yep. Okay. And then we can return, well, here. Let's do this. Array length, split string dot length, and then return array length. Okay. Let's take a look at that. So maybe we should figure out what the answer is first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 words, okay? Let's try this out. Okay, there are 16 words in the string. So the extension is working, but just to try to break our own code, let's add some more spaces in here. Yeah. Something like this. see what happens now. Okay, so now it thinks there's 25 words in the string. So our extension method is, that's because of how we implemented it. So our extension method could be improved. So let's go ahead and do that. This is just a fun side note, really. We can pass in some string split options dot remove empty entries. Okay, so this is an additional way you can configure the call to the split method. Okay, so let's see if that fixes this. Okay, good. And you see that added configuration there brings our word count back down to 16. Okay, so we're looking good there. And one more here. So, right, and so this actually isn't too hard to do. We could do string dot. No, I think it's string dot join. String dot join. How do we want to join the string? We want to join it with a comma. Wait, can we join like that? And yeah, so we could do this here, right? Could do that. We could just do this in line. Right, and that works just fine. Doing that right there. But I don't really like how this reads. It's kind of reads clumsy to me. String.join and then what you're joining with, and then the list that you're trying to join. Like I just don't like how it reads. So we're gonna pick that code up, and we're gonna make it fluent. So public static string to delimited list. And what are we extending? We're extending a list of string, so some list, and then with our separator. Okay, and then we can just return here. Okay, so pass the separator in through here, and then use some list here. Okay, and then now this looks more like some list to delimited list. Right? So to me, this reads nicer. Okay, my grocery list to delimited list, and then how are you planning to delimit it is the parameter here. Okay, so let's see if this still works. And it does. All right, we get our delimited list. Okay, so that's it. Those are the 4 extension methods. And now we have some optional activities here that we'll go ahead and do. So here we're saying, we created these extensions in this common code library, and we might need these extensions in a lot of our apps. And we could just copy paste this file here. We make a common code project somewhere else and then paste in all the C# every time we need this code again. But depending on the situation, we might want to make this library a NuGet package so that we can share this code with the world or with our organization or with someone else. So, and we're going to see how we can do that. So we're going to share this code via the artifact section in Azure DevOps, and we're going to use this NuGet.exe. Okay, so let's take a look at this. Okay, so common code is just it's a DLL file. I mean, we've got some other stuff here, but mostly it's just this DLL file that is the binary code that represents our library here. So we want to create the NuGet package, a NuGet package that we can push to Azure DevOps. And so to do that, we can right click on this and go to properties, and we get this special Visual Studio window for properties. So what we want here is package, and then there's this option to generate a NuGet package on build. So let's do that, and let's give it a name. So let's just call it common extensions, and a description, some methods that I use in a lot of my apps. Okay, good. Project URL, forget about that. Yeah, I mean, all sorts of metadata you can throw in here. Release notes, I don't know, version 1. A lot of stuff here. Okay, so let's roll with this. So now if we go back and do a build, rebuild, and we look back in this folder, or if we go up a few folders maybe. Yep, okay, right here. Common code.1.0.0 NuGet package, right? So this is it. Our code is in here, and we want to push this to the artifact section in Azure DevOps. So yeah, right next to our simple validation library. So to do this, I'm going to click connect to feed, and we want to connect to this feed using the .NET executable. So we can click this here. Okay, I lied. We actually want to connect to this feed using the NuGet.exe executable for reasons that are probably not that helpful to get into. So you'll just take my word for it, and we'll do it this way. So NuGet.exe, we first need to acquire that executable from somewhere. NuGet.exe install. No, don't mind Baconator here. All right, NuGet.exe install. And download. Here we go. And to my downloads. Okay, good. I'm going to copy this, and I'm going to paste it right here, right beside the NuGet package. Okay? And so what we'll do now to push this NuGet package to our feed in Azure DevOps is I'm going to copy this down here, and I'm going to paste it in Notepad. And here there's an alias here for feed for video, and that alias is defined up here. It says feed for video actually equals this value. I don't really want to set this up, so I'm going to copy this, and we just won't use the alias. I'm going to paste the source, right? So this is a URL to our Azure DevOps feed located in the artifact section of our Azure DevOps project. Okay, so that's what that is, and I'm going to copy this command here, and in this folder, I'm going to we'll see NuGet.exe here. I'm going to open in terminal, and I'm going to paste that command in. And I need to modify it slightly. Well, right here. This might be the first time people have seen this. So I've opened a terminal here, and this terminal is operating in the context of this directory in my file system. So if I do ls here, it lists these same files you see here. So let's see, it sees that .NET 7 is a directory, and it sees that these are the two files located in here, the executable file and the NuGet package. And you can do other things. You can cd. So cd stands for change directory. You can cd into net 7.0, and then ls, and then here's all the files that are in that folder. And we can see that through terminal, but you can see the same thing using the graphical interface. All right, and then I want to go back up a directory, so I'll cd ... That brings me back up a directory, which is where I was. Okay, so now I'm going to paste that command in again, and I need to modify it slightly. I need to do that. And I need to put the package name here. So there it is, common code 100 NuGet package. And press enter. And the reason we had to use this one, NuGet.exe instead of .NET.exe, is because I had some issues with the authentication. And what I've been seeing is the authentication's taking quite a long time. So I'm going to cut the video, and then, I'm going to cut the video, and then we'll pick back up after I'm authenticated. Okay, and apparently the package was pushed. Okay, so let's check that out. Go back to artifacts, and then here we can see the common code is now in the NuGet feed. Okay, last thing I want to mention here on the exercise is that we saw with that example that we could create this common class library and reference it from our other projects, but it really wasn't too compelling of a case, right? We had such a small app, and we only had one app, yet we were still splitting code out into another library. So, with the hope that maybe we could reuse it someday, right? So I wanted to show another example here of a larger code base. And so it's located here, and I have it cloned in Visual Studio already, but just kind of want to visualize what it looks like on a larger project. So, here's a large solution, and there's this .NET Common project, class library project, and it has a lot of stuff in here, but it has extension methods as well. So extension methods that have been used a lot. So I have put them in this common class library, and here's some start of quarter stuff. Manipulating date times with time zones and all of that, right? So a lot of stuff in here. Let's see. Let's look at string extensions. Okay, yeah. String trimming, capitalizing and trimming strings, removing white space from strings, putting quotes around strings, serializing stuff, or deserializing stuff, I should say. All sorts of stuff. So, this common code that's been placed in this .NET Common library, and all these other projects are referencing this .NET Common code. If we just open one of them here, okay, if we open any of them except that one, we'll see there's a reference to .NET Common. So almost all of them have a .NET Common reference, and there's actually 3 apps in this solution. So one app is down here, Unified Data Explorer. There's a console application, and there's also an API, where an API is also considered an application from the perspective of this solution. So, and of course, there's a lot of class libraries here that are breaking down code in various ways so that they can be used, with some other pieces of code. So that's kind of a bigger example to visualize here. Okay, that's it for lesson 11.